let's do another example. Let's say if we want to do cosine x times e to the 2 sine of x. Okay, we can even do a definite integral and see what happens. Okay, so whether you are doing a definite integral or indefinite integral, the process is pretty much the same, except when you are doing a definite integral, you need to be a little careful with the upper and lower limits. Okay, we're gonna see what happens. So first of all, you're gonna still recognize your composite function. And basically, a composite function would be the function that looks most complicated. All right, so that's that. And then we can recognize the inner and outer function. So we have our inner function being, I can do 2 sine x. Another alternative you can do is to say u is equal to sine x. Okay, so this is your choice. There is no better choice or worse choice. It's just a choice. Either it works. If it works, it's a good choice. Or it doesn't work, then you choose a different inner function, because that probably just you guessed wrong and you do it again. Okay, so no big deal. All right, so when we do so, then again we follow the protocol. So du is equal to 2 times the derivative of sine, and then don't forget the x. This is important. Now we have upper and lower limits, so you're gonna see what happens when x is equal to 0. Okay, so that's that. This is 0. And what happens when x is equal to pi? So sine of pi, and in this case, it's 0. All right. That's not very interesting. So let me switch up the limits. So let me do a half pi. I apologize for changing the problem, but I just want to make this a little more interesting. So this is equal to 2. All right. Okay. So when you are dealing with a definite integral, you want to be careful with the change of the bounds. All right. So there we go. So here 0 to a half pi cosine x e to the 2 sine x dx becomes, the new lower bound is 0, the new upper bound is 2. E to the 2 sine x is e to the u, and now you have cosine x dx. So from this equation, you group cosine x dx, and then you know this is equal to 1/2 du, so times 1/2 du. Okay, so entire derivative of e to the u is e to the u, so to 2, and then that gives you 1/2 e to the 2 minus 1/2 e to the 0, so this is 1/2 e to the 2 minus 1/2. All right, so there we go. U-substitution, which is the main technique that we'll need for our class.